Hi everyone, welcome back to the channel. Today we are building something extremely powerful, something used by Facebook, Instagram, GitHub, banks, and almost every modern secure platform. A complete multi-factor authentication system in PHP using object-oriented programming. We will be using Bootstrap, Google Authenticator, and recovery backup ports. Now, let me ask you something. What if someone steals your password? What if they guess it, or maybe they saw you typing it? Can they get into your account? Not anymore. Because with multi factor authentication, even if someone knows your password, they still can't log in without a unique one time code generated on your phone. So, here how it's work. First, the user log in normally using email and password. Then the system asks for a 6 digits verification code. This code changes every 30 seconds in Google Authenticator. So unless someone has your password and your phone, they can't access your account. That's security on another level. In this video, we are going to build user registration and login, QR code generation, Google Authenticator integration, session-based security, backup recovery codes, ability to enable and disable MFA, clean project structure with object-oriented programming, and Composer auto-loading. We will create a dashboard where user can active MFA. Once activated, they scan a QR code and Google Authenticator start generating codes. And yes, we are also handling the what if I lost my phone situation. We will generate multiple recovery backup ports that can be used to log in if the phone is lost, just like GitHub and Facebook do. By the end of this video, you will have fully working production ready MFA system that can use in your own project, freelance work, and even client application. So open your code editor, start your local server, and let's build something secure, modern, and professional. Alright, before we jump into the coding part, make sure you have three things installed on your computer. Number one is XAMPP. This will act as our local server and database environment. We will use it to run Apache and MySQL so PHP can execute our project. You can download it from apachefriends.org. Number two is Composer. Composer is the dependency manager for PHP. We will use it to install libraries like the QR code generator and to enable auto loading for our classes. Just go to getcomposer.org, download and install. After installation, open your terminal and type composer-v. If you see the version number, it is installed correctly. Number three is Visual Studio Code. This will be our code editor throughout the tutorial. Make sure to install the PHP extension in VS Code for auto-completion and syntax support. Once you have XAMPP, Composer, and VS Code set up, you are ready to start building the multi-factor authentication system. Alright, so it is time to set up our project structure. So I'm going to create a folder. This will be our project folder. Now inside this folder, I will open the terminal and by typing code full stop, it will open VS Code in the same directory. Now using Control and tilde button, I can open terminal inside VS Code. And for the terminal, instead of PowerShell, I'm using Git Bash. If you want, you can download from the website. Alright, so our terminal is open. Now let's create a structure for our project. So I'm gonna fast forward this section just to make this video shorter. Alright, so our structure is done inside the composer.json. This file basically defines our project dependencies and tell Composer how to auto-load our classes. And as I said, if you want to check for Composer version, just type composer-v and it's gonna show you the Composer version. Now the next step is to actually generate the auto load files. So head over to your terminal, make sure you are inside your project folder and run the command composer dump auto load. Composer will now scan the composer.json file and automatically create a folder called vendor along with the autoload files. Once this is done, next we will install the Android QR code library. For that, you have to type this command. Perfect. Now you can see inside the composer.json we have Android QR code version, and you can also see the library files inside the vendor folder. So that's mean our library is installed successfully. Alright, so our structure is pretty much done. In the next step, we will move on to the database side so we can set up our database and tables. Alright, let's continue. Now we are going to create our database and tables. So first open your browser and in the address bar type localhost phpMyAdmin. This will open the phpMyAdmin dashboard where we manage our databases. On the top, click on the SQL tab. This is where we can directly execute SQL commands. I have already prepared the SQL code that we will create our database and all the required tables. So instead of manually creating each table one by one, we will paste everything here and run it all together. Let me explain what the first part of the code does. The first SQL statement will create a new database where we will store our users. Think of the database as a container that holds our tables like our users table, session, or backup ports. After that, the next SQL statement will create the required tables. The users table will store user information like username, email, password, etc. The backup ports will store temporary login token for multi-factor authentication. You might also notice there is a session table in the SQL. This table is not required for our current MFA system. It is simply there for future use in case you want to experiment with session-based tracking or build advanced feature later. If you don't need it, you can ignore it or delete that part from the SQL. It won't affect our project. Once that is done, scroll down and click on the Go button at the bottom right. You should now see a success message and our database along with all tables have been created automatically. So with the database ready, we can move on to connecting our project to MySQL and start working on the login and registration functionality. Alright, so inside our project folder, let's open db.php file and let's connect our database. So first we start with the PHP opening tags. Next we add a namespace. Namespaces help organize our file and prevent naming conflicts when our application gets bigger. Now we create a class called DB. This class will be responsible for handling the database connection. Inside this class, we define a private static variable named PDO. We make it static because we want the entire application to use one shared connection instead of creating a new connection every time. And it is private so it can only be accessed from inside this class. Next, we create a public static function called init. This function will initialize our connection when called and return the PDO object. We check if a connection already exists. If not, we create one. When we reference self PDO, it means we are accessing the PDO variable inside this class. Now here we create the database connection using PHP's built-in PDO class. We pass three values. First, the DSN which contains the database type and name. Second, the username, and third, the password. Next, we tell PDO to throw exception whenever an error occurs. This makes debugging much easier. Finally, we close the condition, return the connection, and close the class. And that's it. We now have a fully reusable database connection class. So anytime we need a database connection, we just call db init and it gives us the same connection instance. Alright, so it is time to test this out in the browser so we know that our connection is working or not. So I'm gonna open the project folder inside the browser. Next, I'm gonna redirect to db.php file. As you can see, it is a blank page for now. So I'm gonna call that class and I'm gonna pass config.dbarray. As you can see, we are getting errors. So we need to fix that errors because we didn't create a configuration for our database. In the next step, we will work on our config.php file. So inside the config.php, I will create a configuration setting for our database. Alright, so here what is happening in this file, it is a simple configuration file that store all the important settings for our project. First, it has a database details like the host, database name, username, and password. So our app knows how to connect to MySQL. Then it stores the base URL of our project, which makes generating links throughout this app easy and dynamic. Now let's get back to db.php and connect configuration file inside db.php file. Now if we check again, and you can see our error is gone. So that's mean our database connection is now working perfectly. Now let me remove this because we don't need that. We will be using that inside other classes. In the next step, we will create our authentication class. So let's do that. So first we open the PHP tag. This tells the server that everything after this line should be proceed as a PHP code. Here we are defining a namespace called app services. Think of namespace like a folder for your PHP classes. This help avoid naming conflict and keep your project organized. These lines are importing other classes so we can use them inside this file. Use appdb allow this file to access the database class located in the app namespace. And use PDO import the PDO class, which is the built-in PHP database connection class. Now we are starting a new class named Auth. This class likely handle authentication such as login, logout, and checking if a user is logged in. Inside the class, we declare a private property called PDO. This property will hold the database connection object. Marking it as a private means it can only be accessed from inside this authentication class. Next, we define a constructor function. This function automatically runs whenever someone create a new instance of this authentication class. Here we take the PDO object that get passed into the constructor and assign it to the class property we created earlier. This means the auth class now has access to the database connection and can use it for authentication tasks like verifying user credentials. So we have a function called check credentials. This function receives two things, an email and password. The information the user entered when trying to log in. First, we use the database connection to prepare a query. The query look inside the user's table and try to find a record that matches the email the user entered. Next, we execute that query and attempt to fetch a user record from the database. If the email exists, we get the user data back. If it doesn't exist, the function returns false, meaning the login attempt fails. Then we verify the password. We compare the password the user entered with the hash password stored in the database. If the password doesn't match, we return false again and another failed login. But if the email exists and the password matches, the function returns the user's data, signaling a success login. We have a private function called base32 decode. This function takes a base32 encoded string and converts it back into regular binary data. First, we define the base32 alphabet, the characters that are valid in a base32 encoded string. Then we make sure the input is in uppercase so that the function can match each character correctly. Next, we loop through each character of the input. For every character, we find its position inside the base32 alphabet. That position gets converted into a 5-bit binary string, and we keep adding those bits together to form one long binary sequence. Once we have that long sequence of bits, we process it in a group of 8. Every group of 8 bit is converted into the corresponding character. We repeat that until all bits are processed. Finally, the function returns the decoded binary data. In simple terms, this function takes base32 encoded text, convert it into a binary, and return the original raw values. After that, we have a function called verify recovery code. This function is used when a user wants to log in using a recovery code. Usually when they can't access to their two-factor authentication code, the function receives two things, the user's ID and the recovery code they entered. First, we look in the database for all recovery codes that belong to this user and are still unused. We fetch all of those codes and store them so we can check them one by one. Next, we loop through each stored recovery code. For every code, we compare the user's inter recovery code against the hashed version stored in the database. If we find a match, that means the recovery code is valid. Once we confirm the code is correct, we immediately mark that code as used in the database. This prevents the same code for being used again in the future. After updating the status, we return true, letting the system know that the recovery code was valid. If we finish checking all the codes and none of them match, we return false, meaning the recovery attempt failed. In short, we search for the user's unused recovery codes, we compare them securely, and if there is a match, we mark it as a used and approve the login. Alright, so now we are inside a private function called HOTP. This function generates one-time password, the password which is used in two-factor authentication. First, the secret key that was stored in a base32 format gets decoded into raw binary data. This gives us the actual secret key and used to generate the OTP. Next, we take the counter value which increases every time a new code is generated. and convert it into 8-byte binary format. This is required because the HOTP standard works by hashing the counter and the secret together. Then we create a hash using HMake function with the SHA-1 algorithm. This step mixes the secret key with the counter to produce a unique result. After that, we use something called dynamic truncation. We extract a portion of a hash based on a calculated offset. This is a part of official HOTP algorithm and ensure end up with numeric value. Finally, we converted that truncated value into a number, remove the signed bit to keep it positive and take the last 6 digits. That gave us the 6-digit one-time password. In short, we decoded the secret key, mix it with the counter, extract a portion of the result, and generate a 6-digit OTP code. Alright, so after HOTP, we are in a function called verify TOTP. This function checks whether the 6-digit code the user entered is valid. The code from an authenticator app like Google Authenticator. First, we determine the current time slice. Time-based code change every 30 seconds. So we divide the current time by 30 and use that value. Next, we create a small loop. We don't just check the current 30-second window, we also check the window just before it and the window after it. This gives the user a little flexibility if their clock is slightly off. Inside that loop, we generate an expected code using the HOTP function we already explained it. Then we compare the generated code to the one the user entered. If the code matches, the function returns true, which means the code is valid. If none of the time window produce a match, we return false, meaning the code is invalid. So in summary, we calculate the current time slice, we check a range of nearby time windows, and we return true only if one of them produce a matching code. Alright, after that we are in a function generate backup codes. This function create multiple backup recovery codes for user. The kind you can use it if you lose access to your Authenticator app. First we set up an empty list that will store the newly generated codes. We also prepare a database statement that will insert each code into the database. Then we start a loop that runs as many times as the number of backup codes we want to create. By default, that is 8 codes. Inside the loop, we generate a random codes using cryptographically secure random bytes. This ensures each backup code is unique and safe. Next, we hash that code before storing it in the database. Only the hashed version gets saved. The real code is never stored in a plain text, which keep it secure. We then insert the hash code into the database for this specific user. Finally, we save the plain backup code into our list so we can return it to the user later. Once the loop finishes, we return all generated backup codes. These are the codes the user can print or save them somewhere safe. In short, we generate secure backup codes, hash them, store them, and then return the plain version for the user to keep safe. Now we are inside a function called use backup codes. This function allows a user to log in using one of their backup recovery codes. First, we look in the database for all backup codes that belong to this user and are still unused. We load those codes so we can check them one by one. Next, we loop through each unused backup code. For every code, we compare the code to the user entered with the hashed version stored in the database. If we find a match, that means the backup code is valid. Once we confirm valid code, we immediately update it record in the database and mark it as used. This ensures the same backup code cannot be used again. After marking it as used, we return true, telling the system that the login is allowed. If none of the code matches, we return false, meaning the backup code was invalid. So, in summary, we check the user's unused backup codes, we verify if the entered code matches, and if it does, we mark it as a used and allow access. Alright, next we create a function get provisioning URL. If you see a URI, it's a mistake, so consider it as a URL. This function generates a special link known as provisioning URL. This is the link that apps like Google Authenticator use to automatically set up two-factor authentication for a user. First, we create a label that includes both the issuer name, usually your application's name, and the account name. We encode it so it is safe to include in a URL. Next, we build a parameters for the URL. This includes the secret key, the issuer name, the security algorithm, the number of digits the OTP code should have, and how often the code changes, which is every 30 seconds. Finally, we return a special formatted URL. This link can be turned into a QR code which the user scans with their Authenticator app to set up two-factor authentication. In simple terms, this function builds the QR code link used by Authenticator app to connect with the user's account. Finally, we are in a function of this class called generateSecret. This function creates a brand new secret key for two-factor authentication. First, we define a set of characters that can be used in the secret. These characters follow the base32 standard, the format required for app like Google Authenticator. Next, we start building the secret string. We loop for however many characters we want. By default, that is 16. During each loop, we randomly pick one character from the allowed set and add it to our growing secret string. The randomness comes from cryptographically secure function, which make the secret safe and unpredictable. Once the loop finishes, we return the completed secret key. This key will later be used to generate one-time password for two-factor authentication. So in short, we randomly assemble base32 string that become the user's unique two-factor authentication secret. And that's it for our authentication class. In the next video, we will be working on our user model. And if you are new here, make sure to subscribe our channel so you don't miss the second part of this series. Thanks for watching and I will see you in the next part.